Honors Algebra 2 Pre-Calculus. We're doing Pre-Calculus section 9.3, which is geometric sequences and series. And in this video, we're going to talk about the nth term of a geometric sequence, which is on page 635 of your textbook. So before I give you the formula that's on page 635, let's logic through this again, right? So we have some sequence that we are told is geometric, right? So we have this geometric sequence, up to the a sub nth term, keeps going. Okay, and what we know about these terms is we know that they have a common ratio r, meaning to get from a sub 1 to a sub 2, I would multiply by r, and to get from a sub 2 to a sub 3, I'd multiply by r again, and to get from a sub 3 to a sub 4, I'd multiply by r again, etc. So what I want us to realize is that we could actually rewrite this sequence so that it looks like a sub 1, well, a sub 2 is the same as a sub 1 times an r, right, times that common ratio. What that means is that a sub 3, which was a sub 2 times a common ratio, should be a sub 1 times 2 of those r's, right? Because it would be, if a sub 2 is a sub 1 times r, then a sub 3 would be a sub 1 times r times another r, right? And then the same logic would take us to a sub 4, which would be a sub 1 times r squared times another r, so a sub 1 times r cubed. What I want you to notice is that each one of these terms essentially has one fewer r than the term number, right? Because a sub 1 didn't have to get multiplied by r, he was just the first term to start with. So my a sub n is going to be a sub 1 times r to the n minus 1. And that's the formula you're going to see in your book, is that a sub n is a sub 1, meaning the first r that you start with, times r to the n minus 1, right? And that's the gist of the formula that we're going to use. So what we're going to do now is we're going to go ahead and find some nth terms, find the formula for the nth term and then use the formula for the nth term. So let's go ahead and walk through an example 2. All right, so in example 2, we're going to find the formula for a sub n, and then we're going to use it to find a sub, I don't know, let's just go with 8, fine by me. Okay, so my sequence that I'm going to give you is going to be let's do 120 and a 30 and a 15 halves and a 15 eighths. Okay, so this is definitely geometric, right? Because what I'm doing essentially is dividing by 4 each time, right? So what I'm doing is dividing by 4, and you can see that pretty quickly if you look at the relationship between these two, right? So I'm timesing by a fourth, which is the same as dividing by 4. You can check that by timesing 30 by 4, and by 1/4 rather, and you get 30/4, which is the same as 15 halves. So if I times by a fourth, and then sure enough, if I times 15 halves by a fourth, I get 15 eighths. So seems to me that my r is 1/4, and my a sub 1 is 120, right? Well, if I know a sub 1 and I know r, then in order to find my a sub nth term, right, it's going to be a sub 1 r to the n minus 1. So my a sub nth term in this problem is going to be a 120 times a 1/4 to the n minus 1, right? So this is my nth term, right? It's my formula for my nth term. That's the first thing I was asked to do. Then I was asked to use that, right, to find a sub 8, which would be a 120 times this 1/4 to the 7th, right? Now, you can find 4 to the 7th on your own if you really, really want to. It's up to you. I'm not going to. I'm going to type in 4 to the 7th on my calculator. So I'm going to get that this is a 120 times a 1 over 16, 3, 8, 4, right? So I'm going to get that the 8th term is a 120 divided by 16, 3, 8, 4. Great. That's fine. If you want to simplify it, you can, right? You can make your calculator do that. I'm not sure if you're familiar with it. You can do a 120 divided by 16, 3, 8, 4, right? And you can get a decimal. And if you hit math and then frac, it'll turn it into the lowest terms fraction for you, which is 15 over a 2048. So anyway, that's my a sub 8, right? 15 over a 2048. All right, cool. We're going to keep doing some other examples now. Let's do another example where I give you some missing pieces to a sequence and you have to kind of fill in the gaps. All right, so in example 4, I'm going to give you so we're gonna find the 10th term in a geometric sequence whose second term is, we'll do 5, and whose let's see, second, third, sixth term is 80. All right, so let's give that a try. So find the 10th term in a geometric sequence whose second term is 5 and whose sixth term is 80. Now, there are a couple ways to do this. You could find a formula for the nth term, although I didn't expressly ask you to, so you don't have to. There are a few ways to look at this, right? So one way to do this is to go ahead and figure out those blanks like we've done before, right? So don't know the first term. Second term is a 5. Third, we don't know. Fourth, fifth, sixth is an 80. 7th, 8th, 9th, 10th. This is the one I want, right? There's a couple different ways to do this. One option is to go ahead and fill in the blanks like this, and that's great. There's nothing wrong with that because especially in this case, I'm only using the second and the sixth term, which are pretty close together. So you could figure out, hey, I'm timesing by 1, 2, 3, 4 R's, right? So you could say to yourself, oh, 5 times R to the 4th gives me 80. R to the 4th, oh, this is clever. There's actually 2 possible answers here. Well, sort of. There's 2 different possibilities for R. R to the 4th is 16. So when I take the 4th root of R, remember that when you take an even root, like a 4th root, you have to write a plus or minus. So there's 2 possibilities. R could be 2 or R could be -2. And the reason that's possible is let's look at those 2 possibilities, right? So let's, I'm going to put another blank space down here where I do the exact same series. 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the one I want, right? So this is a 5 and 3, 4, 5, 6. This is an 80. Okay, so in either way, there's only one possible answer for the right answer here, but I want to show you why there's 2 possibilities for what the R value could be. So in this top one, I'm going to say, hey, what would happen if R was 2, okay, in this top example? So since I only want the 10th term, honestly, an easy option is to just kind of fill in the gaps and times things by 2, right? So I know that R is 2, so this must be, and you can actually double check that you're right by working your way backwards, right? Divide by 2. So 40, 20, 10, oh look, it comes out when I divide by 2 to a 5, and this would be a 5/2 or a 2.5, right? And if I go the other way, I'd get a 160 and a 320 and a 640, right? And I'd get a 1,280, right? So that's my answer, right? My answer is that the 10th term is the 1,280, and that's fine, right? So that's one way. And now, but let's say what had happened if R had been a -2, right? And again, it's going to turn out the answer is physically the same, but I want to show you why it matters that the R could be 2 different values. So if R is a -2, then when I go backwards, I'm not dividing by 2, I'm dividing by -2. So it'll be a -40, and then a +20, and then -10, and then look, it's still a +5, and then this is a -5/2. Great. If I go the other way, right, when I times by 2, this will be a -160, right, and then it'll be a +320, and then it'll be a -640, and then again, it won't matter here because I'm going to get a +1280 again. But if instead of asking you for term 10, I'd asked you for term 9, I would have had to give you more information, or I would have had to ask you for both of the possible outcomes, right? So in this situation, when R was -2, I get a very different sequence. Same concept, but the signs are alternating, right? So there are 2 different ways to do this. Now, there is another way to do this problem. The other way to do this problem, if you weren't going to draw this all out, is essentially similar to what we did with arithmetic sequences before, right? So we already know the answer is a 1280, and that's fine. And we already know that the common ratio is either a 2 or a -2. But there is another way to do this. The other logical way to do this, right? So if you didn't want to write it all out like that, the other logical way to do it is you could say, you know how we saw that a sub n was a sub 1 times r to the n-1? Well, just like we saw with arithmetic sequences, there's a reason that it's an n-1. It's because, sorry, I was trying to find a different color and found the same color, because it's an n-1. So you could actually use this same trick if you wanted to find, let's say you know a sub, so for instance, in this problem, you know a sub 2 is 5, and you know a sub 6 is 80. So you could actually use this to find r. You could say, oh, a sub 6 should be a sub 2 times r to the 6 minus 2, right? By the same exact formula, but instead of it being an n and a 1, it's a 6 and a 2, right? And sure enough, you'd get that 80 equals this 5 times r to the fourth, and you'd very quickly get the same r is plus or minus 2, and then from there, you could say, cool, since I know a sub 6 is 80 and I want a sub 10, right, I could say that a sub 10 equals a sub 6 r to the 10 minus 6, right? So I would get that a sub 10 is the 80 I had times, essentially, it doesn't matter if it's a plus or minus 2 to the fourth, because since it's a fourth, it's going to come out positive either way. You'd get that a sub 10 is an 80 times a 16, right? Which is definitely still going to give you that 1280. Right? So again, different ways to do the same problem. I always did it as the way where I wrote out the lines and I wrote out the whole sequence, and that's the way I did it forever until somebody thought of this in one of my classes. And that's one of the cool things about being a teacher, is sometimes a student comes up with something really dope, and then you can use it and say, hey, this kid came up with this, because sometimes other people see things that we don't. Again, this is a great plan if you get it, but I think maybe doing it this way, it might have been harder to spot the plus or minus 2, and you'd have to be a little bit more mindful of that. The other thing to be mindful of is that not everybody's going to spot this pattern, and that's fine. If you want to write it out, that's great. Writing it out is also totally fine pretty much in any situation, as long as the two terms are fairly close together. If instead of giving you the second and the sixth term, I gave you the fifth term and the 500th term, then writing out the lines is going to be absolutely ludicrous and is not is sort of an untenable solution. Like, you would not be able to write out 500 spaces. That would be a weird choice. Anyway, there you go.